Task 3.6. Select and determine cryptographic solutions. One of my favorite topics. Let's get started. And remember, if I don't go as deep as you would like, that's what the prompt at the end is for. Alright, this section has 5 subtasks, which include the cryptographic life cycle, cryptographic methods, public key infrastructures, key management practices, and digital signatures and digital certificates. Each of these are very crucial to understanding cryptography in general, but all over the exam we require that we use this for our access controls and other security measures. The cryptographic life cycle, a very key concept. It starts with key generation. For the exam, you need to understand that creating strong, random cryptographic keys of the appropriate length is essential. The strength of your entire system will depend on the quality of your keys. Algorithm selection. You're going to use AES for symmetric encryption. You're going to use SHA for hashing. But your asymmetric algorithms, especially with quantum threats, well, we'll see where we go there. Key management might be the hardest part and most tested on the exam. That involves the secure storage, distribution, rotation, and revocation of cryptographic keys throughout their life cycle. The exam often includes questions about best practices in key management. Poor key management can undermine even the strongest system. And cryptographic agility. That's a newer concept that's gaining importance. It refers to designing systems that can easily transition between algorithms to address evolving threats and standards. So like TLS, we can change algorithms, right? I'm not locked into anything. As you prepare for the exam, remember that these elements of the cryptographic life cycle don't exist in isolation. They're interconnected and form the foundation for many other security concepts we have discussed or will be discussing later. Cryptographic methods. This is a fundamental area that the exam frequently does test on. There are several key cryptographic methods you should be familiar with. One, the algorithm types. So I mentioned symmetric and asymmetric as well as hashing. Symmetric was when you have the same key for both encryption and decryption. We mostly think about AES today, and we use it because of its speed. All data is encrypted symmetrically. Asymmetric encryption originally was how to encrypt the symmetric key, Diffie-Hellman, but now we have other ones that allow us to sign as well. We think of elliptical curve and RSA as our two most popular asymmetric algorithms. We may need to go to post-quantum soon, and NIST has already selected them. Don't worry, the internet's not going to break if quantum computing ever works. Elliptical curve is a type of asymmetric algorithm, and it's the most efficient way we should be doing it. This is the way Bitcoin signs things, and it's the way the ISC2 likes to agree on keys, I notice, whenever I sniff out a TLS handshake with them. Quantum cryptography is not the same as quantum computing. This is like the Diffie-Hellman of quantum computing, but it's more for key generation. So quantum encryption is when I use quantum technologies to generate true random numbers, and it allows for the detection of a hacked key. This is already out, by the way. And hashing. This is the third algorithm type that we use for checking the integrity of the data. When you encrypt or authenticate a hash, you create a digital signature, and again, that's with the sender's private. And remember, these cryptographic methods don't exist in isolation, right? They're often used in all parts of our other domains. Public key infrastructures. We use symmetric keys to encrypt data. We use hashing to check the integrity of data, to ensure only that identity gets the key to the symmetric key, or only that identity sign the hash. We have asymmetric encryption, and the public key is associated with your identity. Well, we need a public key infrastructure to manage identities. Some key components you'll need to know for your exam. The certificate authority is a trusted entity that issues and manages digital certificates. The exam might test your understanding on the CA and any intermediate CA's role in a PKI system. 2. Registration authorities. These are the entities that take your application. It's like applying for a driver's license. You have to first prove identity, and then they'll receive it and then send it out to the DMV. The digital certificate is your actual identity. It's your public key that's been signed by the CA or some intermediate CA that has all of your directory information in there. And in case just like your driver's license doesn't have written on there when it's revoked, there has to be a system that allows people to be notified when a public key has been revoked. And that's digital revocation lists, which actually be certificate revocation list checking, which kind of a really old school, and we prefer to use OCSP, the online certificate status protocol, wherever it's available. Key management practices. I told you this could be very big on the exam. I don't care how strong your locks are. Where are the keys? So mismanaged keys, mismanaged security. For the exam, please understand several practices. Key generation and derivation. This involves creating strong keys using random number generators and key derivation functions, and we talk about a few of them in my class. The CISSP exam might test you in your understanding of what makes a good, strong key and the importance of true randomness in key generation. Key rotation. This practice involves regularly changing cryptographic keys to limit the impact of potential compromises. The exam may ask about the benefits of key rotation and how often the keys should be rotated in different scenarios. Key revocation. This is the process of invalidating a key before its expiration date in your asymmetric systems, usually due to a compromise or maybe a change in the key holder status. Understanding when and how to revoke keys is very crucial for the exam. And key destruction. But what it really means is when you no longer need that password, don't reuse it. Well, the same thing here. These practices are to ensure that keys are no longer needed have been decommissioned. Remember, these practices are closely tied to all kinds of other parts of the exam. Digital signatures and digital certificates. So we mentioned the concept before. Digital signatures is when somebody encrypts or authenticates a hash with their private key. Well, they're asymmetric. Someone would need the public key to validate it. That's your ID card. So digital certificates are when you take your public key and get it signed by the CA, it becomes a validated certificate. Digital signatures are cryptographic techniques that provide authentication, integrity, and non-repudiation of a digital message. For the exam, understand that digital signatures use asymmetric encryption methods and hashing techniques. Digital certificates are the electronic documents that are the public key that binds it to the private key of the owner. They are typically issued and trusted by an intermediate CA below a root CA. Non-repudiation means that the sender can't deny it, because if that public key decrypts it, that private key was used. It provides a zero-knowledge proof. And integrity, because of the hash, a digitally signed document or code has also been validated for integrity as well. Now, as you prepare for your exam, consider how digital signatures and certificates relate to each other and to other topics we've covered. Alright, summarizing our task 3.6 here, we explored cryptographic life cycle. That includes key generation, algorithm selection, key management, and cryptographic agility. We discussed various cryptographic methods such as symmetric for data, asymmetric for keys, symmetric keys, and authenticating hashes, and of course our hashing algorithms for integrity. We examined the public key infrastructure and the various components, including root CAs, intermediate CAs, and the digital certificates that are validated public keys. And we covered key management practices in general, emphasizing proper key generation, rotation, revocation, and destruction. And finally, we tied it all together with some digital signature stuff and digital certificates. All right. Remember to try out your knowledge on the prompt that follows. All right, come on, check it out. Try out your knowledge, try out your understanding. Modify line 5 and say, I need to go deeper. Larry just kind of glanced over this. All right, see you soon.